Good morning, children. Today I shall teach you about the electronic configuration of elements. We know that the distribution of electrons in various orbits or energy levels of an atom such as K, L, M, N, O, P, Q is known as electronic configuration. There are 7 orbits or there are 7 cells or energy levels are used to distribution of the electrons of an atom of element. So the first orbit is denoted by K, second is denoted by L, third is denoted by M, fourth is denoted by N, fifth is denoted by O, sixth is denoted by P, and seventh is denoted by Q. So this is the first orbit, it is the second orbit, this is the third orbit, fourth orbit, fifth orbit, sixth orbit, and seventh orbit. So all the electrons are distributed in only the 7 orbits. Number of electrons will be in orbits according to the formula of 2n squared. So number of electrons are in orbit. Number of electrons are in orbit is 2n squared, where n is equal to 1, 2, 3, 4, 5, 6, 7. So in first orbit K has number of electrons is equal to 2 into 1 squared is equal to 2. Number of electrons in L is 2 into 2 squared is equal to 8. Number of electrons in M orbit 2 into 3 squared is equal to 18. The number of orbit N means fourth orbit which have the electrons 2 into 4 squared is equal to 16. Number of electrons in fifth orbit 2 into 5 squared is equal to 50. Number of electrons for the sixth orbit P equal to 2 into 6 squared is equal to 72. And number of electrons in seventh orbit Q 2 into 7 squared is equal to 98. So here the first orbit has only the capacity to store the 2 electrons, L 8 electrons, M 18 electrons, and this is the 32 electrons, the O 50 electrons, the P 72 electrons, and Q 98 electrons. So one rule is there are 4 suborbit, means the minimum suborbit is found in orbit is 1 and maximum 4 suborbit is found, because the S has 2, there are 4 suborbits. There are 4 suborbits. Which name is given S, P, D, F. S has only the 2 electrons found in it. P has 6 electrons. and D has D has 10 electrons, means 2 electrons, 6 electrons, 10 electrons, and D has 14 electrons. D has 14 electrons. Fourteen electrons. 14 electrons. So K has only one suborbit because it has also the 2 electrons. So due to it has one suborbit S. But L has the 8 electrons due to it has the S and P because it has acquired the 2 electrons. P has the 6 electron. M has S, P, D. And N has S, P, D, F. And after that, the repeated S, P, D, S, P, D, F, and S, P, SP means SPDF means 2 electrons plus 6, 8 plus 10, 18 plus 14 means 32 plus 34 plus 6, 40, and D means they are repeated as P, D, F dot 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 as P, D, F dot dot dot. So here this is the K has only one suborbit, L has only two suborbit, M has three suborbit. After that, all the other orbits N, O, P, Q have all the four suborbits, and these suborbits also distributed the electrons, and then we can explain the electronic configuration. Now we shall discuss about the electronic configuration. Electronic configuration is of the sodium. Sodium which atomic number is 11, then we can write here the 1s2, 2s2, 2p6, 3s1 means 2, 2, 4 plus 6, 10 plus 1, because 1s2 it represents the k orbit, 2s 2s2 and 2p6 represent the L orbit, and 3s1 represent only M orbit. So here its electronic configuration is also written as 281 means KLM. Second, this is the calcium. Its atomic number is 20. Then we can write here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So here also it represent here. This is the K L M. K L M means here K L represent the 8 electrons, M represent the 18 electrons, but here is 6 plus 2, 8 plus 2, 10. So here it represents the KLM. So this is the electronic configuration one rule is also how to electron filled in the SPDF subcells. So we can make the one formula, one adjustment, and we can write here, this is the, because S suborbit are found in all 7 orbits. So we have draw the 7 blocks for the S. 1, 2, 3, 4, 5, 6, 7. So 1S, 2S, 3S, 4S, 5S, 6S, and 7S. Now we have the P found in not in a K orbit, it start to in L orbit. Due to it start to 2P, 3P, 4P, 5P, 6P, and 7P. D found start to from the M orbits. So it start to 3D, 4D, 5D, 5D, 6D, 7D. Then F suborbit start to find from the N orbit. Due to we write here 4F, 5F, 6F, 7F, 7F. Now the adjustment, first of all we have electrons moves in first suborbit S, then electron moves in suborbit 2S, then electron moves 2p to 3s fulfilled, then 3p to 4s, 3d 4p, then 4d 5, then 4f 5d 6 to 7s, 5f 6d, then 6f 7d, and we get here. So here we also find the electronic configuration through the SPDF is here first of all we have oxygen, its atomic number is 8. Then we start to fill the first suborbit 1s, means 1s2, then 2s2, then 2p4, because p has the 6 electrons but here oxygen has the 8 electrons, then 2 electrons complete fulfilled by the S suborbit, then also 2 electrons fulfilled by the 2s suborbit, then only 4 electrons left behind, then P is only filled by the 4 electrons. This is the electronic configuration of the oxygen through the SPDF suborbits. For example, we have taken the magnesium, its atomic number is 12, then we have written here, because this represents also K, it represents here L, because L has the 8 electrons, then only the L completed from the 6 electrons. But magnesium have the atomic number is 12, then we write here 1s2, 1s2, 2s2, 2p6, 2p6, 3s2, 3s2. So this is the electronic configuration of magnesium, in which K has the only 2 electrons, L has the only 8 electrons, and M has the only 2 electrons. So here this is the electronic configuration of the oxygen and magnesium. It is also written as here it is also written as 2 6 2 2, it is also written as 2 8 2. So the number of electrons in last orbit is called its valence electrons. Number of electrons last orbit is known as its valence electrons. So we can explain about the electronic configuration of elements. Thank you.